So, what's with the cheerleader? Well, two things. Firstly, I wanted to welcome you to Senior Maths Methods. And secondly, I just wanted to give you a little prompt by reminding you about what an AP is. 2, 4, 6, 8. An AP is defined by its first term, T1, in this case it's 2, and the common difference between each successive term. In this case that's 2 as well. What does successive mean? I hope you know. Anyway, to be successful this week, you need to be able to answer 4 questions. Firstly, what is an AP? What does it look like? What does it do? Secondly, can I calculate a specific term using the recursive definition? Recursive means we're repeating the same pattern. So if we start with some general term, Tn, who knows, maybe that's the 17th term. And I want to know what the next term is, maybe the 18th term. All I do is I add on that common difference number, and that tells me what the next term is. So I take a term, I add the common difference, and that tells me the next term, Tn plus 1. If I want to work out any general term in a sequence, not just the next term, I need to use a formula. Now I said earlier an AP was defined by 2 things. What were they? An AP is defined by the first term, T1, and the common difference. You need to take the first term and add the common difference onto it n minus 1 times. And that'll let you calculate the nth term or the general term or any term in the sequence. And finally, if I've got a sequence of numbers, 2, 4, 6, 8, can I calculate the sum of these terms even if there's a really large number of terms? I can. So I use an S to represent a sum or a series. So the sum of n terms is, we need to know the first term, T1, and the last term, Tn. Tn is the last term because in this case I'm adding up n terms. I average those two, so the average of the first term and the last term, and I multiply that by how many terms? N. Remember, n always represents either the number of terms you're looking at or the specific term you are looking at. So T17 would be the 17th term. S17 would be the sum of 17 terms. And there's some criteria for n. It's always 2 things. N is always positive and a whole number. So what did I expect from you this week? Well, if you're in my class, and probably any other class, I expected you to organise your notes and practice questions under clear headings. You should have downloaded the textbook. You should have organised the class OneNote on your computer. I hope you've started a formula sheet because as you've just seen above, there's at least 3 new formulas. And I hope you've made a note of when your assignment is coming. If you don't know, perhaps have a look at the course overview in the content library of this OneNote. I might just add one more formula. It's not one you need to know, but I like to think of it as a bit of an extra trick or an extra hack. It might save you from having to use simultaneous equations if you don't like doing that. So if you don't know the common difference in an AP, but you do know some term, and you do know some other term, let's say you know the 32nd term and the 12th term or something like that. So I'll just use B and A to represent those. You can calculate the common difference. So for example, if the third term is 7 and the 5th term is 13, and maybe I'm asked to work out the general term for this sequence, well, I'll need to know the first term and the common difference. So to work out the common difference, I say, well, that's just going to be the later term, T5, minus the earlier term, T3, divided by 5 minus 3. And thusly, I can work out the common difference. And once I've got that, it's much easier to work out the first term or any other term I want to know. So that's one way of avoiding simultaneous equations if you want to. Alrighty. So here we have Mr. Snuffles. Mr. Snuffles is in training. He wants to swim all the way to Stradbroke Island for a holiday and he's working up to it. On the first day of training, he swam a total of 500 metres, and each day he swims 50 metres further than the previous day. Is this an AP? It is, because we have a first term, 500 metres, and we know that there's a common difference. We're adding the same amount every day. So I want you to do questions A, B, C, and D. Pause the video now, and then we'll talk about what the answers are. Alrighty, 1150 metres is the first answer. I hope you got that. The next answer is 1200 metres. Sure, that's easy. We've just got to add 50 onto our last answer. But I just wanted to point out some language here. Hence. If you see hence in a question, that means you need to rely on information that you've just worked out or information that was just given to you earlier. So you can't just come up with the answer of 1200. You need to say, because the last term was 1150, therefore the next term is 1200, or something like that. And one way to do that is the recursive definition, which you're also required to use in this question. And when you try to use the recursive definition, as you're required to do, you will have to rely on that previous term, 1150. So you will be addressing that hence part of the question. If you're not sure what I'm talking about, find me and ask me, or maybe ask someone else. Okay, part C, in total, so we're adding up terms now. How far was swum over the first 15 days? (12,750 metres or 12.75 kilometres if you like. And finally, part D. How many days of training until Mr. Snuffles reaches his goal of Stradbroke Island, which is 3 kilometres from his backyard? So that's how many days. I need a number of days, of course a whole number, and then comment fully, and you can read the rest. So I need two things. I need to know how many days, and I want a full comment on whatever that sentence says. And I'm expecting to see that in the comments of this video. Good luck, and welcome to Maths Methods.